Welcome friends, my name is Satyajeet Sahu and we are in Champion series. In Champion series today we are going to see what? Steel structures, and today we'll see what? Riveted and bolted connections. Okay. So welcome Juhi, Vivek, Rasmita and Nikki. So the comments are appearing here, so I will be seeing the comments here. Yes. And welcome Anu also. Very good. Welcome to everyone. Yes. So a short introduction about myself and then we will start the lecture. My name is Satyajeet Sahu. I have done my BTech and MTech both from IIT Kharagpur. I have 10 plus years of teaching experience in the field of GATE, ESE and other civil engineering examinations. Okay. So I have given GATE also, and through GATE only I was selected into many of the PSUs, SPCL, IOCL, RITES and DMRC. Okay. So I have given ESE also. In ESE I have a marks of 140 in the ESE interview in 2016, which is considered one of the highest in the country. Okay. I have worked as design manager in Delhi Metro Corporation. Okay. After that I have been teaching for the GATE students and ESE and other state examinations, and I have experience of teaching in more than 15 states all across the nation from north to south, east to west, and I teach all the civil engineering subjects and general studies. So let us start today's lecture. But before that, as we have started this new trend, what is the new trend? That we'll be seeing the number of days left for the upcoming examination. So for SSC we have 46 days. Okay, so you should gear up. Yes. And for GATE we have 128 days. Okay, and for ESE prelims we have 143 days. So these are the days left, so you should start studying and becoming serious. So welcome Saurabh Sri also. Welcome Saurabh Sri. Okay, so let us start today's lecture. But before that, one small announcement. On 1st of October morning 11 a.m. 1st of October morning 11 a.m. we are having our scholarship test. If you want to appear for the scholarship test to avail the full courses, then you can register, okay, in this particular scholarship test. This scholarship test will be conducted where? In the official app. Okay, so you can download BYJU'S Exam Prep official app that will be available in the Play Store, and then you can register for this particular scholarship test. Okay, so let us start our session. Pardon, I will have some water. Little coughing came. Okay. So everyone is ready? Shall we start then? So we'll start with bolted connection today. There is some problem with my throat. Just can you pardon me for 1 minute? There is some problem with my throat. I'll have some more water. Okay. So first we'll start with what? Bolted connection. Okay. So in bolted connection, first we'll see a typical bolt. A typical bolt will have three parts. You can see the bolt diagram is there. So it will have three parts. You can see in this bolt, we have a shank area. This is known as what? The shank area or the shank portion. Yes. And this is known as the threaded portion. This is known as what? The threaded portion. Okay. This is known as the head of the bolt. And you can see that below the head, okay, and here we have what? The washers. They are known as what? The washers. And then we have this nut. We have this nut. Okay. So how bolting is done? Very simple. Suppose we have two members like this. Suppose we have two members like this. So what we do? First of all, we'll make a hole and then we'll place the bolt like this, right? We'll place the bolt like this. Yes, this will be your shank portion, and then will be the threaded portion. Then it will be what? The threaded portion. Okay, and then this is the head. Okay, then here we'll place the washer first. Here we'll place the washer first. This is the washer. This is to hold the members. And then we will place the nut and tighten it. Then we will place the nut and tighten it. So this is a typical bolt. It's a typical bolt. Now first of all, let us see some specifications about the bolt. Let us see some specifications about the bolt. The first specification is the grade of bolt. It's what? The grade of bolt. So when we are writing grade of bolt, okay, it is expressed in this manner. Either they will express like 4.6 or 8.8, something like this. Now this is what? This is in the format x dot y. You can see it is in the format what? X dot y. Now what this x is, what this y is, let us understand. So this x is what? If you multiply 100 to this, we will get the yield strength of bolt. Now bolts are prepared from what? They are prepared from steel, right? Bolts are prepared from steel. And we know that if we draw the stress versus strain curve of a steel, then we get a curve something like this, right? Initially there will be a straight portion and then something like this. This is, I can say, the stress versus strain curve of a steel. Here you can see we have two important points, right? One point is this, one point is this, right? Now this point is what? This is the yield stress. And this point is what? This point is the ultimate stress, right? So this is the, I can say, what will the Fy be? I can say this is what? This is the yield stress. Yield stress, or I can say yield strength. You can say what? Yield strength of bolt. It is the yield strength of bolt, okay? And what is FUB? FUB will be the ultimate strength of bolt. FUB is ultimate strength of bolt. Understood? Sorry, I just miswrote it. So if you multiply 100 with x, we get what? FUB. Means what? This x indicates what? It indicates a number. When you multiply it by 100, you get what? The ultimate strength of bolt. So tell me, when I am telling 4.6 grade, what is the ultimate strength of this bolt? Can somebody tell me? Can you mention in the comment section? What will be the ultimate strength of this bolt? FUB, when it is written 4.6, tell me. What will be your answer? What will be your answer? Yes, it is 400. You see, in this 4.6, we can say x is 4, right? So what you do? 4 into 100 gives me what? 400 Newton per mm square. This is the way we find out the ultimate strength of a bolt, okay, from its grade. Now, what this 0.6 indicates? Let us understand what this 0.6 indicates. Now here, this point y is the ratio of the yield strength of bolt and the ultimate strength of bolt. So when I write point y, it is what? The ratio of yield strength of bolt and ultimate strength of bolt. Now tell me, for this 4.6, what will be FYB? Tell me. What will be FYB? Tell me. From this understanding. From this understanding, I can say that 0.6 or 0.6 is equal to FYB by FUB, okay? And FYB of FUB have already found out, it is 400. So FYB will be equal to 0.6 into 400, giving me how much? 240 Newton per mm square. Understood this? Yes. Similarly, tell me for 8.8, what will be FUB and what will be FYB? What will be the ultimate strength and what will be the yield strength? This is what is a grade of a bolt. Okay. So this is how it is indicated, and this is how we find out the ultimate and the yield strength of a bolt. Now tell me, what is the ultimate for this particular grade 8.8? The ultimate one will be how much? It is 800, right? I can say here x is 800, x is 8 and y is actually 8, or I can say point y will be 0.8, right? So here it will be 8 into 100, 800, very good. And FYB is how much? FYB is 640. Very good, Ashish. Very good, Juhi, Karthikeya, Santu, everyone. Great, great doing. So everybody now understood what is a grade of a bolt. And from the grade of the bolt, how to find out the ultimate strength and the yield strength. Very good. Next thing is the diameter of a bolt. Here you see, we have seen that this is the sank portion and this is the threaded portion. Okay, threaded portion, yes. The sank portion is also known as the gross portion, the gross area, and this threaded is known as net area. Yes. Now when we say the nominal diameter of bolt, it is the sank diameter. It is what? The sank diameter. Okay. So from here, I can find out what? The sank area of bolt. In your steel chapter, subject, in steel subject, there are so many terminologies. Yes. And how to just write down the names? Very easy. You see, it is what? You see A for area. Okay. Now it is which area? Sank, S. So I write on what? Sank area of bolt. And it will be how much? The bolt cross section will be circular, so it will be pi by 4 into d square. Pi by 4 into d square. Now tell me where the area will be more, in the sank portion or the threaded portion or net portion. Where the area will be more, sank portion or the threaded or net portion? Tell me. Where the area will be more, tell me. Where the area will be more? Sank portion, yes. We can see that if we redraw it, I am just redrawing it. It will be something like this, right? You can see it will be something like this. Yes, it will be something like this. I am not drawing the head. So you can see that this is D. So sank area will be more. And as per our IS code, the net area of bolt, this is what? The net area of bolt. The net area of bolt is 0.78 times of the sank area of bolt. This you have to remember, and this is as per which code? This is as per IS 800, the code for steel. Okay, so this thing you have to remember. So I can say the net area of bolt will be how much? It will be 0.78 times of the sank area, or 0.78 times pi by 4 into d square. So this we understood what? The nominal diameter of the bolt. Now the bolts will go inside what? Inside the bolt hole. Yes, and obviously I can say that this is suppose the cross section of a bolt which is diameter d. It will go inside what? A bolt hole. So obviously the diameter of the hole should be larger, right? Obviously I can say that the diameter of the hole, yes, I will call that as d naught. Obviously the d naught will be greater than d. Or I can say that the d naught will be d plus some clearance, I can say, right? I can say some clearance. Some clearance. Now how to find out that clearance? How to find out that clearance? That will depend on what? The diameter of the bolt. So if, to remember it, if the diameter is between 16 to 24, I have done like this, it is between what? Diameter is between 16 and 24, and it is what? Including 16 and 24, right? Including 16 and 24 mm, yes. That time, this clearance value is what? This clearance value is 2 mm. And when the diameter is less than 16, this clearance value is 1 mm. And when the diameter is greater than 24 mm, this clearance is 3 mm. So I can say from here that the whole diameter is equal to what? The bolt diameter plus 1. This is also equal to the bolt diameter plus 2. This is also equal to the bolt diameter plus 3, depending on the diameter of the bolts. This is for what? Where the diameter of the bolt is between 16 and 24. Yes, you can remember this much only. See, if you remember 16 to 24 now, you remember other things also, right? Yes, yes. and this is D is less than 16, okay, D is less than 16 and here D is greater than 24 mm. Here D is less than 16 and here D is greater than 24 mm. Understood everyone? Very nice, you understood. So now tell me for 12 mm what will be if the bolt diameter is 12 mm, what will be this hole diameter? Now fill in these blanks. For 12 mm it will be how much? For 12 mm it will be 13. For 14 mm it will be 15. For 16 mm it will be 18. For 18 it will be 20, then 22 to 24, right? 26. For 27 mm it will be 30 and 33 and 36. Yes? So you can see that when it is above 24, the D naught will be what? D plus 3. Yes. When it is 16 to, when it is between 16 to 24, it will be what? D naught is equal to D plus 2. Yes. And when it is less than 16, I can say it is your D naught is equal to D plus 1. So everyone understood this, right? Everybody understood this. So the next specification, that is what? The pitch distance. The pitch distance. Now what is pitch distance? You can see these are the bolts, right? The bolts. The pitch distance is the consecutive distance between the bolts. It is what? The consecutive distance between the bolts. This is what? The pitch distance. Or I can say center to center distance. Yes, center to center distance between the bolts. Okay. But this is center to center. Even this is also center to center, right? Even this is also center to center. This is also center to center. But which one is the pitch? Remember that this is center to center distance between the pitch in the direction of load. You can see that the load is applied in this manner, right? The load is applied in this manner. So it is in the direction of load. Direction of load. Okay. This is known as what? Gauge length. This is known as what? Gauge length. Yes. Gauge length is what? It is perpendicular to direction of load. Okay. Very simple concepts. So I can say that both pitch and gauge length as what? Are the center to center distance. Both are what? Center to center distance between consecutive bolts. Yes, between consecutive bolts. Okay. But when it is in the direction of load or direction of force, direction of load or direction of force, then I will call this as the pitch. And when it is in the direction perpendicular to force, right? Perpendicular direction of force, right? Or perpendicular to direction of force, then it is what? The gauge length. Understood? Now, there are certain specification about the pitch distance. Okay? So the minimum pitch distance is equal to, remember this, it is 2.5 times of the bolt diameter. It is what? It is 2.5 times of what? Bolt diameter. Remember this. You have to remember these things. Okay? Small things. We'll solve questions also. Don't worry. Have little patience. We'll solve questions also. The minimum pitch is what? It is 2.5 times of the bolt diameter. 2.5 times of what? The bolt diameter. Very good. Very nice. Beautiful. Very good. Okay. Now don't confuse. Some students get confused. It is bolt diameter or hole diameter. It is bolt diameter. This is what? D. This is your bolt diameter. Then what about the maximum pitch? The maximum pitch depends on that is a tension member or a compression member. See, suppose we have a connection like this. Okay. Suppose we are bolted like this. I will not draw. Suppose there is a member and there is tension acting. Means what? Axial tension acting. Then it's a tension member. In that case, the maximum pitch is equal to 16T or 200 mm, whichever is minimum. whichever is minimum, we take that as the maximum pitch. Okay, and what is this T? We'll be connecting two members. Suppose I'm connecting two plates here. Suppose I'm connecting two plates here. Something like this. I have connected two plates here. Okay. Now suppose this is your T1 thickness. This suppose T1 thickness, and this is your T2 thickness. Yes, T2 thickness. And I have connected this through bolts. I have connected through those what? This through bolts. Yes. So here in this equation, T is what? T is the minimum of, it is the minimum of T1 and T2. It is the minimum of what? T1 and T2. Very good, easy. Minimum of what? T1 and T2. Understood everybody? Yes. So I can say thickness of what? Thinner plate, right? Thickness of thinner plate. Yeah, it is available on the app. Okay, we are taking full courses of GS on the app. Okay, so our in the batches, GS का जरूरत है, so you can register for our courses. We are taking the GS courses also. Okay, we are taking all the GS courses on the app. Okay. Okay, so 16T or 200, whichever is minimum. Understood? This is what? This is the maximum pitch. Now this is for a tension member. This is for a tension member. For a compression member, this maximum pitch will be equal to, instead of 16T, it will be what? 12T and 200, whichever is minimum. Whichever is minimum. For example, if I say that this T1 is suppose 12 mm and this T2 is suppose 16 mm. Okay, suppose this is there. And I'm asking you, what is the maximum pitch? What will be the answer? Tell me. What will be the answer? Tell me. For this, suppose it's a tension member. Suppose tension is acting like this. Tension is acting. Okay, tension is acting like this. Okay. So tell me in this case, what will be the maximum pitch? Please tell. What will be the maximum pitch? Here take the thinner member. So T will become what? T will become 12 mm. And then we will take what? 16T is out. 16 into 12, that is 192. So we will compare 192 and 200. And which is minimum? Minimum is 192. So here the answer will become what? 192. Understood? So like this, you should be able to find out what the maximum pitch distance. And this is for the compression member. You will see difference between tension member and compression member is, this tension member is 16T, compression member is 12T only. Yes, very good. Now next is Gauss distance. The Gauss distance we have already discussed, right? It is what? The center to center distance between the consecutive bolts in the direction perpendicular to the bolt. The next thing is end distance. What is this end distance? This end distance is, you see, this is the corner bolt, I can say. Okay, from the corner bolt to the end of this particular member. This is what? The end distance. This is the end distance. We have another distance, that's the edge distance. What is this edge distance? This is also from the corner bolts to the end of the member. You can see this is end of the member. This is also end of the member. But this is known as the edge distance. And this is known as the end distance. E for end distance, E naught for edge distance. Now what happens here, you see, how to know which is end, which is edge. You see, this end distance is in the direction of load, right? You can see, this is also what? You see, this is also end distance. It is in the direction of load. Whereas you see this edge distance, this is edge distance, even this is edge distance, and even this is edge distance. It is what? It is in direction perpendicular to load. So I can say this is the distance in the direction of stress or what? Load from the center of the bolt hole to the end of the element, or I can say member. This is what? The end distance in the direction of load. Yes. And what is your edge distance? Yes. Edge distance, you can see all these are what? Edge distance, this is edge distance, this is edge distance. All these are what? Edge distance, this is what? The distance perpendicular to direction of load. It is not load, it is load. Understand everyone? No separate course. No, there is no separate course. You have to take it with the full course. Obviously, there is no separate course available. Yeah, there is no separate course. It is full ESE. Okay, so separate course is not available for time being. Okay, next we'll go to the specification for bolted joint, minimum end distance or edge distance. Okay, so what will be your minimum end distance or minimum edge distance? The specifications are same. It is equal to 1.5 times of the hole diameter. Okay, 1.5 times of the hole diameter if you are making the holes in machine. So it's machine cut. It's machine cut. It's also equal to 1.7 times of the hole diameter if we have hand cut. Now obviously nowadays machine cuts are used, yes or no? So I can say by default this is the minimum end distance or edge distance. Okay, this is the minimum end distance or edge distance. Okay. So now ladies and gentlemen, one small point I want to mention here. If you remember, what was the minimum pitch distance? The minimum pitch distance was 2.5 times of D. So here students get confused, therefore I want to tell both of the points together, that the minimum pitch is 2.5 times of D, where it is what? The bolt diameter. It is what? The bolt diameter. Whereas the maximum pitch is, the minimum end distance or edge distance is what? It is 1.5 times of D naught, where D naught is what? Hole diameter. So these 2 points I want to mention together because students get confused in this. Hope it is clear now. Now what about the maximum end distance or edge distance? The maximum edge distance or end distance is 12 times T into epsilon. What is this T? This T is the thinner plate. It is what? The thinner plate or thinner member. And what is this epsilon? This epsilon is root under 250 by Fy. Okay, where Fy belongs to the plate. For example, if I'm saying, just for example, if I'm saying that I'm connecting two plates, 12 mm and 14 mm. Okay, and suppose Fy is your 250 MPa only. Now tell me what will be a maximum edge distance? What will maximum edge distance tell me? Tell what is the maximum edge distance in this case? Yes, it will be what? You see 12, thinner plate is what? This is the thinner plate, so 12 mm, right? So 12 into 12 and epsilon will be what? 1. So the answer is what? 144 mm. Okay. Now based on all this specification, let us solve some objective questions. Okay. Okay, this is the first question. Now tell me the answer to this. The first question, tell me the answer to this. The minimum pitch for a bolted connection made by M18 bolts. What's the right answer to this? Please tell. The minimum pitch for a bolted connection made by M18 bolts. So minimum pitch, okay, so minimum pitch is what? Ladies and gentlemen, the minimum pitch is 1.5 times of D. So this is what? 1.5 times of D is, here it is written M18. So this M18 is what? You see, whenever I write in M18, this indicates the diameter of the bolt. It indicates what? The diameter of the bolt. So here the minimum pitch will be how much? 1.5 into 18, that is how much? Why have I written A? Sorry, 2.5, sorry, 2.5, sorry. 2.5, the answer is how much? 45. Understood? Very simple, very easy. Okay, very simple, very easy. Next question, yield strength of bolts of grade 5.6. Answer this. Yield strength of bolts of grade 5.6? Answer this question. Yield strength of bolts of grade 5.6. No B, Vivek. Yield strength means what? FYB. Yes. See, from this grade, I can say FUB will be equal to 5 into 100, giving me 500 MPa, right? And you see this 0.6 will be the ratio of what? FYB by FUB. So from here I can say your FYB will be equal to 0.6 into 500, giving me how much? 300 MPa. Yes, the answer is this. Very good, very good. Next question. Okay, answer this. Minimum edge distance for a bolted connection using what? M20 bolts. So when I say M20, here D is your 20 diameter. This M20 means that indicates the diameter. What's the answer to this? C. C. Yes. Minimum and this edge distance is what? Nothing is mentioned. I will assume machine cut, but it is what? D naught, hole diameter. So the minimum edge distance will be, or end distance will be, same thing, 1.5 into 22. Because when this is 20, it is lying between 16 and 24. So the hole diameter will be what? 20 plus 2, that is equal to what? 22 mm. Yes. So it is 1.522, that is how much? 33 mm. Very good. Next question. Maximum pitch for a flat. Flat means a plate. Flat means a plate. Okay. Tension member of thickness 12 mm being connected to a gusset plate. Gusset plate is another plate, okay, of thickness 16 mm. And it's a tension member. So maximum pitch they have asked. Answer this. Tension member, maximum pitch. Answer this. Very good, very good. Maximum pitch I told for tension member is 16 T or 200, whichever is minimum. And T is the thinner plate. You can see the thinner plate here is 12 mm. So it is minimum of 192 and 200, right? So that is how much? 192. So right answer is this. The next question. Ratio of sank area and net area of a bolt. The ratio of sank area and net area of a bolt is how much? Ratio of sank area and net area of a bolt is how much? Okay, why it is 1? Why people are writing B? Huh? See, the net area of bolt is what? That is 0.78 times of sank area of bolt. So, the ratio of sank area of bolt and net area of bolt will be how much? 1 by 0.78. This I am getting 1.28. Understood? So, answer is C. Next question. The design yield stress for 9.8 grade bolt. Similar question we have solved. So, the design yield stress for 9.8 grade bolt will be how much? How much? The designed yield stress for 9.8 grade bolt is how much? Okay. From here, FUB will be equal to 900 Newton per mm square. Okay. And your FYB will be equal to what? 0.8 into 900, giving me how much? 720. Next question. Okay. The ratio of minimum pitch and the maximum and the minimum edge distance for a bolt of diameter 18 mm. So minimum pitch and minimum end distance ratio. Tell me what is this? How much answer are you getting for this? So the minimum pitch distance by the minimum end distance is what? It is, you see, minimum pitch is 2.5 into d, and this is 1.5 into d naught. Yes. So this gives me 2.5, d is given 18. So d naught will be how much? It will be 20, right? Yes, 20. So we cancel, I am getting a 12 here. And you can see that I will get a 8 here. So 12 by 8 is how much? 1.5. So these are some of the specifications of the bolted connection which can be asked directly in the examination. Okay. Now about riveted connections, okay, or riveted connections, I will be conducting a session on 6th of your October. On 6th of October morning, 6th of October morning 11 a.m. So this was sort of a what? You know, just for bolted specifications I conducted this class. Okay. So 6th of October morning 11 a.m. I am conducting a session for what? A session for your HPCL, well, and your TS PSU examination. So that time I will be discussing what? Riveted also. So I am not discussing here riveted. So I will be discussing riveted and bolted connection and many other specifications like this on that particular day. So this brings us to the end of today's lecture. Today's lecture was short. Okay. Today's lecture was short. It was about the specifications of bolted connection. Okay. Some other day in YouTube. Yeah, in YouTube. Okay, on YouTube only this will be conducted. Like today we morning had for geotech, na? Morning we had for geotech. So we will have for your riveted and bolted and other steel specification, not only riveted and bolted, and other codal provisions of steel. Okay. So this we will have on this. So like this we will have, you know, I will tell theory and then we will solve questions. I will be solving around 50 to 60 questions. Like today morning we solved for geotech and now also we solved 10 questions around, yes, for the bolted connection, the specifications. Like this I will be conducting a session. Therefore I thought that let us not have a repetition because that day we will be solving more questions. So this is sort of a what? We can say in this manner we will be seeing the steel structures. Hope you enjoyed this particular lecture. So tomorrow at 10:45 p.m. night, so this was today's lecture. So tomorrow at 10:45 p.m. I will be conducting a session on what? On your flexible payment. So please attend the sessions. So you can see that I have designed these sessions so that it is not only helping for your GATE examination, but for other examinations like what? SSC, JEE, BEL, HPCL, TS, PSC. So many examinations are in line. So therefore, I am designing this, sessions in such a way that it will help you in the upcoming sessions, okay, upcoming examinations other than GATE also. Thank you very much. See you tomorrow 10:45 p.m. for flexible payments. And also on 6th October, we'll be meeting for the steel structures also. Thank you very much. Bye.